Welcome back, everyone. Today we're doing a deep dive into something a little different. It's a student-created resource for learning about wave physics.
Okay.
So we'll be exploring what makes this specific resource unique and valuable,
Right.
and how it showcases the potential of open educational resources,
Okay.
or OER,
Yeah.
and student-driven learning.
Sounds good.
Our source material comes from a website called Open Educational Resources, Open Source Physics at Singapore,
Okay.
which is this amazing collection of interactive physics simulations and learning materials. And get this,
Yeah.
the specific resource we're looking at was created by a student named Boone Sheen.
Wow.
And it's even been turned into apps that are available in the Apple App Store and Google Play Store.
That's impressive. So what makes this simulation stand out from the crowd? There are a lot of wave learning tools out there.
Right, exactly.
What's special about this one?
Well, for one, it goes beyond just the basics.
Okay.
You can actually use it to really delve into complex concepts like wave interference.
Ah, I see.
You can actually see how two waves interact to create those like intricate patterns,
Right.
which is super important for understanding things like diffraction and superposition.
Yeah, those can be tough to grasp just from reading a textbook.
Exactly. So I was curious,
Yeah.
what kind of waves can it simulate? Like, does it stick to just the simple stuff? Or can it handle more complex types of waves?
You know, the website doesn't specifically list every single wave type that it can handle,
Okay.
but just from the sections that they have on their wave superposition and general waves, it seems like it can handle both transverse and longitudinal waves,
Yeah, cool.
which are the main types you usually encounter.
Right.
But what really sets it apart, I think,
Yeah.
is that it visualizes wave interference in a way that traditional methods just struggle with.
That's what makes it so valuable, right? Like actually being able to see these concepts in action.
Exactly.
It makes them click so much easier than just like trying to memorize definitions.
Yeah, absolutely.
It's like you actually grasp how waves behave.
I think that's key.
And another cool thing
Yeah.
is that users can actually like manipulate different parameters,
Okay.
like the amplitude, the frequency,
Yeah.
the wavelength. So
Right.
it's not just watching a preset animation.
Oh, okay.
It's like a hands-on experience,
Cool.
like a playground for exploring the world of waves.
Yeah, I can see how that would be really engaging for students.
I can imagine spending hours myself just like tweaking the settings and seeing what happens.
Yeah.
But speaking of accessibility, you mentioned earlier that this simulation is available on the web,
Yeah.
but also as a dedicated app.
Right.
What do you think about that approach?
Well, I think that multi-platform approach is fantastic for accessibility
Okay.
because it caters to different learning styles and, different technology preferences.
Yeah, that makes sense.
Like some people might prefer using a web-based tool on their laptop, but others might find it easier to use a dedicated app on their phone or tablet.
Right, exactly.
So by offering both options, you're basically guaranteeing that the resource is going to be available to a much wider audience.
Like having a portable physics lab in your pocket.
Ha, yeah.
It just opens up so many possibilities for how this could be incorporated into learning.
Yeah,
I
definitely.
mean, just imagine, you could use this in a classroom setting,
Right?
and students could be using their phones to adjust wave parameters,
Okay.
and then you could project the results in real time on a shared screen.
Uh-huh.
It would totally transform a traditional lecture
Yeah.
into this dynamic, interactive experience.
I like that.
And that's just one example.
Yeah.
It really highlights how powerful interactive simulations can be
Yeah.
for enhancing traditional teaching methods and getting students more engaged.
And it's not just the simulation itself. Right.
Oh, that's true.
The creators went above and beyond, and they actually included a bunch of supporting resources as well.
Really?
Lesson plans for teachers,
Huh.
worksheets for students,
Oh, wow.
and even videos that illustrate some of the key concepts.
That's awesome.
Yeah, so it's like this really holistic approach to learning,
Right.
and it's clearly designed to guide users through the material and make sure they really get it.
I did notice that they specifically mention worksheet activity 1.pdf and worksheet activity 2.pdf.
Oh, interesting.
Do we know what those worksheets actually cover
Mm.
or how they're supposed to be used with the simulation?
We don't have the actual content of those worksheets.
Okay.
But I think it's safe to assume that
Yeah.
they're meant to complement the simulation and give students a chance to apply what they've learned,
Okay.
maybe through some hands-on exercises.
That makes sense.
Yeah.
So they really have thought of everything.
That seems like it.
They even link to other relevant tools as well,
Yeah.
like Jujalobra and Firefox.
Oh, cool. Can you remind me what those are exactly?
Yeah, so GeoGebra is a platform for creating interactive mathematical and scientific visualizations.
Right, right.
So users can explore concepts like geometry,
Okay.
algebra, calculus,
Mm-hmm.
and it's all in this really dynamic way.
So how would that connect to the wave simulation?
Well, you could use it to create visual representations of wave equations,
Ah, I see.
which would then complement the visual approach of the simulation.
So it's about connecting the visual representation with the underlying math, right?
Exactly.
Cool.
And then PHYPHOX
Yeah.
stands for Physical Phone Experiments.
Okay.
It's this really cool app that basically turns your smartphone into a science lab.
Wow.
You can use it to conduct actual experiments
Wow.
using the sensors that are already built into your phone.
That's amazing. So does it directly interact with the wave simulation?
You know, it might not directly interact with the wave simulation,
Okay.
but it definitely encourages that hands-on experimentation, which helps to solidify those concepts that you're exploring in the simulation.
Right, right.
So they're encouraging you to take your learning beyond the screen
Yeah.
and into the real world.
That's a great approach.
But before we get too carried away
Mm-hmm.
with all the specifics of this one simulation,
Yep.
I think it's important to take a step back
Yeah.
and look at it within the bigger picture
Okay.
of open educational resources
Yeah.
and the open source physics movement.
Absolutely. That's important context.
So tell me a little bit about that.
Well, this simulation really embodies the principles of open educational resources,
Yeah.
as we call them, OER. And these are materials that are free for anyone to use,
Right.
adapt,
Mm-hmm.
share.
Okay.
So the idea is to remove barriers to education
I like that.
and make learning more collaborative.
That makes sense.
And open source physics takes this concept a step further
How so?
by focusing specifically on physics education. And they provide all these tools and resources for both teachers and students.
Right.
And what's really cool about this particular simulation
Yeah.
is that it was created by a student.
That's awesome.
It really shows how much potential students have to contribute to OER.
It definitely challenges the traditional model
Mm-hmm.
where knowledge flows from the teacher to the student.
Right.
But in this case,
Yeah.
you have a student who not only understands a complex topic,
Mm-hmm.
but they've actually taken the initiative to create a tool
Yeah.
to help other people understand it.
It's pretty inspiring, actually.
It is. And to
Yeah.
think this is just one of many resources on this website.
Right.
It's amazing.
It really is like a treasure trove of knowledge just waiting to be explored.
Okay, so now I'm curious.
Yeah.
What do you think the broader impact is
Mhm.
of this simulation
Okay.
and others like it? How can these kinds of things shape the future of physics education?
Well, interactive simulations have this unique ability to take these abstract concepts
Okay.
and make them tangible.
Yeah.
They can bring physics to life in a way that textbooks and lectures sometimes struggle to do.
I agree.
You know, they can deepen understanding,
Right.
spark curiosity,
Uh-huh.
even inspire a love of learning
Yeah.
in students who might have felt intimidated by the subject before.
And I think for student creators like Boon Sheen,
Yeah,
there are even more benefits.
right.
Like, they gain a deeper understanding of the subject themselves just by going through the process of creating the simulation.
Right. And on top of that,
Mm-hmm.
they develop valuable skills
Okay.
in programming,
Mm-hmm.
design,
Mm-hmm.
problem solving.
It's a win-win situation.
Absolutely.
And it speaks to a future
Yeah.
where students aren't just passive recipients of knowledge.
Right.
They're active creators and contributors.
Exactly. And I think as more high-quality OER like this become available,
Mhm.
we're getting closer to a world where access to education is determined by your thirst for knowledge, not by your financial resources,
I like that.
which is something I'm personally very excited about.
Me too. And I think this wave simulation is a fantastic example
Mm-hmm.
of what that future could look like.
Absolutely. Yeah, it really is a pretty big shift, isn't it?
It is.
We're moving away from just passively absorbing information.
Mm-hmm.
And now students can actually be involved in creating their own learning experiences,
Right.
even contribute to the resources that other
Yeah.
people are using.
Yeah. And it's empowering.
It is.
You know, I was thinking about something you said earlier
Yeah.
about using this simulation in a classroom setting.
Okay.
How do you actually picture that playing out?
Yeah.
Like, I can see it being used in a traditional lecture format,
Right.
but do you think there's more to it than that?
Oh, I think it can definitely go beyond just a lecture.
Okay.
Imagine this.
Yeah.
You've got students working in small groups.
Hmm.
And
Hmm.
each group has a tablet or a laptop,
Mm-hmm.
and they're running the simulation. But the task is for them to design their own experiments.
Oh, interesting.
They could manipulate the different variables to test their own hypotheses about how waves behave.
That's a great idea.
Yeah.
It encourages collaboration,
Yeah.
problem solving, critical thinking,
Absolutely.
all while they're learning about wave physics.
Exactly.
And what would the teacher be doing in this scenario?
I think the teacher would act more like a facilitator,
Okay.
guiding the students, asking questions to make them think deeper,
Right.
and encouraging them to share what they're learning with the rest of the class.
That sounds like a much more dynamic and engaging way to learn.
Definitely.
It also makes me think about personalized learning.
Oh, yeah.
Like a student who's struggling with a particular concept could spend extra time on that part of the simulation.
Right.
While a student who's already got the basics down could move on to the more advanced features.
That's one of the really cool things about these interactive simulations. They can adapt to different learning paces and styles.
And then with the additional resources like the lesson plans and the worksheets, teachers can really tailor the learning experience to each student.
Exactly.
Speaking of those worksheets, do you think their main purpose is assessment? Or are they meant to serve a broader purpose?
I think they probably do both.
Okay.
On the one hand, they could be used to assess how well students understand the material.
Right.
But I think more importantly, they're designed to get students actively involved with the simulation.
Okay.
Like they might ask students to make predictions, to design their own experiments, analyze data, or even come up with their own questions about wave behavior.
So it's about pushing them to go beyond just passively taking in information.
Exactly.
And really become active learners.
I think that's a key shift in thinking.
It is.
And it aligns perfectly with the whole philosophy of open educational resources. It's about giving learners the power to take charge of their own education.
Right.
And to see themselves as active participants in the learning process.
I like that.
And, you know, it's easy to get caught up in the details of this specific simulation.
Right.
But we should remember that it's just one example of a much bigger movement.
That's true.
This whole world of open educational resources.
It's amazing how many resources are out there.
There really are tons of them.
Simulations, interactive tools, lesson plans, all kinds of educational materials.
Covering pretty much any subject you can think of.
And the best part is, it's all freely available.
Right.
Which is a game changer.
It is.
Especially for students who might not have access to traditional educational resources.
Absolutely.
It really democratizes access to knowledge.
Yeah.
And it opens up so many possibilities for learners of all ages and backgrounds.
It really does.
So this wave simulation is a testament to the creativity of these student developers and to the transformative potential of open educational resources.
Definitely.
But I think there's another side to this that we haven't talked about yet.
Okay.
What about the downsides?
Right.
Or the challenges that come with this movement?
Yeah, that's a valid point.
What are some of those?
While OER obviously has a ton of benefits, there are some potential challenges to consider.
Okay.
One concern is quality control.
Right.
Because anyone can create and share educational materials now. It's really important to make sure that those resources are accurate, reliable, and pedagogically sound.
That's a really good point.
Yeah.
How do we ensure quality control in a system that's so decentralized?
There are a few things we can do.
Okay.
Peer review is one of the most important. Having educators and subject matter experts actually review and vet these materials can help to make sure they're accurate and effective.
And the platforms themselves, like the one that's hosting this wave simulation, they can play a role too.
Absolutely.
By curating high-quality resources and highlighting the ones that have been peer-reviewed.
Exactly.
So it's about building systems and communities that prioritize quality assurance.
Right.
Even though it's a decentralized environment.
I think that's key.
What about sustainability?
Oh, yeah, that's another big one. Creating and maintaining high-quality OER takes a lot of time, effort, and resources.
So how do we address that?
Well, we need to find sustainable models that can support the development and distribution of these resources.
Are there any models out there that you think show promise?
There are some promising developments.
Right.
Some institutions are starting to incorporate OER creation into their faculty workload.
Interesting.
So they're recognizing the value of OER and giving their faculty dedicated time and resources to create these materials.
That makes sense.
And other institutions are looking at community-based development models, where educators collaborate to create and share resources.
That's a cool idea.
Yeah, it's about finding creative solutions that are also collaborative and that recognize how important OER is.
And that provide the support that's needed.
Exactly.
For these resources to continue to grow and develop.
I think that's crucial.
It's exciting to see this shift happening in education.
It really is.
We're moving toward a model that's more open, collaborative, and accessible.
And I think ultimately that benefits everyone.
I agree. This really does feel like we're at the start of something big.
Yeah.
And it's not just about making education cheaper.
Right.
It's really about changing how we view knowledge creation and sharing.
It is. And open educational resources, they challenge the whole idea that knowledge is something you buy or sell. You're all about sharing and collaboration and continuously making things better.
It's kind of like the open source movement.
Yeah.
But applied to education.
Yeah.
And just like open source software has led to so many innovations.
Absolutely.
I think open educational resources can totally revolutionize learning.
I think so too.
Just imagine.
Yeah.
Textbooks aren't these static,
right,
expensive things anymore, but they're these dynamic, interactive resources.
Okay.
And they're constantly being updated and adapted
Yeah.
by a whole global community of educators.
That would be amazing.
And think about students in remote areas. They would have access to the same high-quality materials as students in big cities.
Exactly.
It levels the playing field
Yeah.
and opens up opportunities for everyone.
That's what's so great about it.
It breaks down those barriers.
Yeah.
And it encourages collaboration.
And it lets learners take control of their own education.
And it all starts with people like Boon Cheen,
Right.
who are willing to share what they know and share their creativity with everyone.
It really is inspiring to see students like him shaping the future of education.
Makes you think about the ripple effect.
Yeah.
It's not just the students who use the simulation,
Right.
but it's the impact it has on the whole educational landscape.
Absolutely.
By creating and sharing this resource, Boon Cheen has contributed to this growing body of knowledge.
Yeah. That's accessible to anyone, anywhere.
It's amazing.
He's helping to create a more equitable learning environment for everyone.
And that's really what it's all about, right?
It is.
It's about encouraging people to love learning, empowering individuals, and creating a society that's more informed and engaged.
That's a great way to sum it up.
And that's something we can all be a part of.
We can.
Whether we're teachers or students or just lifelong learners.
Absolutely.
So as we wrap up our deep dive into open educational resources, I want to leave our listeners with a challenge.
Oh, okay.
Go out and explore this amazing world of OER.
Yeah.
Discover all the incredible resources that are out there.
There's so much to find.
And think about how you can contribute to this movement.
Exactly.
Whether you're trying to learn more about a specific subject, or improve your teaching, or just explore new areas of knowledge. OER has something for everyone.
It does.
And remember,
Yeah.
it's not just about using these resources.
Right.
It's about engaging with them, adapting them,
Yeah.
and sharing them with others.
Absolutely.
Be an active part of this global learning community.
I love that.
So go explore.
Yeah.
Create.
Share. The future of learning is in our hands.
It really is.